Welcome back to BAI's Engineering Knowledge Series, the place where we speak to the specialists that make everything in broadcast transmission happen behind the scenes and gaining insight from them on the roles they play to keep broadcast services to air 365 days a year. My name is Masood Rasuli, Head of National Broadcasters at BAI Australia, and this is episode 3. So last time when we got together, I asked you to leave your living room and head to the outdoors. Scan the horizon and marvel at the beauty of the country and let your eyes catch a glimpse of the towers on the horizon. I want you now to trek all the way to that tower until you see a building at the base of it. Try to picture what's in there. What is it that makes you able to watch your TV and listen to your radio? We know it takes electricity, an antenna and a tower, but what are the missing pieces here? How does the signal get to us, and how is it that you can enjoy your favorite shows 24/7, 365 days a year? Today, we have Jeff Dale, RF Systems Manager, and Matt Betts, RF Systems Team Leader at BAI Australia, to help fill that gap and share with us the roles they and their teams play in making the signals always available for us to see our favorite shows and listen to them. Jeff and Matt are the engineering design authorities on all things RF in the broadcast network. Guys, welcome.
Thanks, Maz.
Thanks, Maz.
So, Jeff, can you tell us a little bit about what you do at BAI and also what your team does? Because it's quite a big team.
So, as you mentioned, I'm the RF Systems Manager, and my RF Systems team has quite a bit of diversity in it, as well as a breadth of responsibility. So, starting off with RF design. So, Matt is our RF design team leader. Our RF design team looks at engineering designs and standards. They develop scopes of work and conduct feasibility assessments for the various projects that occur throughout the network. We have an RF networks team who provides specialist support to engineers and technicians based around the country. When they strike issues that they need support with, it's our RF networks team that provides that support. RF networks also develops equipment guides and they look after technical training as well of our teams. We have a repair and calibration team based in Brisbane. They gather failed equipment from around the network and focus on its repair, as well as the calibration of test equipment. And the stores and management of spares as well. And finally, we've got a PSN integration team. That team looks after the expansion of the New South Wales Telco Authority's public safety network in New South Wales. And there's obviously a bunch of project work associated with that as well.
Sounds like you've got a lot to keep you busy there, Jeff.
Yeah, it's a broad role, but a good one.
Excellent. Well, look, you mentioned Matt and RF design, so why don't we jump over to Matt now, and he could tell us a little bit about design standards and why they're so important.
As you say, the design standards are quite important for the teams. So our team manages the RF design standards. So they're the standards to which we would build the new transmission systems. So those standards include things like defining the program input equipment, defining what are the acceptable transmitters that we would use in the network, likewise combiners as well, and things such as the earthing standards as well.
With the standards, how, I guess, to what extent are they important around not just the design and build, but the ongoing maintainability of the services and the equipment?
Yeah, so they're quite important. So it defines for the SIU team, the team that manage the system on a day-to-day and look after the systems on a day-to-day basis. It lets them know exactly what they need to use in terms of the equipment, how it should be connected, and so that they know that when they go to one site to the next, that they should expect to see a similar build between each of the sites, so they can easily manage the system without having to work through multiple different designs to work out what's going on each site.
Mm-hmm. And obviously that leads to greater uptime and service restoration, obviously.
Yeah, so certainly the intent of most of our standards, or in fact all of our standards, is to make the systems that we provide as resilient as possible, so that the uptime is as high as possible.
I'm sure the customers appreciate that, Matt. So you mentioned the program input equipment. So tell us a little bit more about the affectionately known as the Pi. The Pi. Tell us a little bit about
Yep.
a little bit more about Pi and what they do, and also, how critical they are in the broadcast chain.
So the Pi is as you say, is the program input equipment. That's the equipment that takes the input signals, the programs from the distribution system that comes from the studios through to the transmitters. So the Pi essentially allows us to have multiple inputs that we can switch. If we have a failure on one input, we can switch to another. So it enables us to provide seamless redundancy within the network to keep the services on air for as long as we can, and to a high quality.
Excellent. And so moving on from the Pis now to the transmitters, can you tell us how, I guess, the Pi interacts with the transmitter, and then tell us a little bit about our transmitters?
Okay, so the Pi essentially takes a signal from the distribution system, which could be, depending on the customer's, a satellite distribution system, or over the DVN, which is a digital video network, or a direct link from the studio. And so we take the signals from that, put it through some switching equipment, and in some cases we do some processing, a minor amount of processing to make sure that the signal is exactly what we need to put into the transmitters. So that processing is really just around ensuring we've got the right levels for the transmitters to operate correctly. So the transmitters, my team's responsible for doing the designs for any transmitter replacements, part of the selection team for new equipment types for the transmitters. So we're currently going through a process of selecting some new low-powered FM transmitters at the moment. So we're going through a process of assessing various vendors' products to make sure that we've got a good selection of equipment going forward.
Does that include things like the transmitter configurations as well?
Yeah, so certainly when we're selecting transmitters, we're looking at their performance level to make sure that their performance is what we expect, and we also look at the way we're going to configure them, so the way we're going to achieve redundancy within the transmitters. So, for example, we've just finished a rollout of high-powered FM transmitters where we've configured them as N+1 services. So we have one spare transmitter for a number of main transmitters on site. So that number's usually between 2 and 5 main transmitters.
That's pretty clever.
It is.
It offers quite a bit of flexibility there, and presumably this all happens either automatically or remotely. We don't necessarily need to deploy someone to site.
Yeah, that's correct, Maz. So they're set up to automatically switch to the highest priority service that has failed, and then it will. The systems we have in place will switch if a higher priority transmitter fails, it will attempt to switch the lower priority transmitter back on air. So we might have a failure where a transmitter's on low power, and so the first step is to switch the full power redundant transmitter on. But if a higher priority transmitter fails at the same time, it will switch to the higher priority and then try and switch back the partially failed transmitter to air, so we've got a service to air, even if it's not the full power service.
Not full power. And with these newer transmitters, are we finding that they're a little bit more efficient, and how they sort of stack up against the previous generations in terms of, I guess, the amount of heat that they put out and the power that they use? So
certainly in terms of the DTV transmitters, the current generations of transmitters are 2 to 3 times more efficient than the previous generation that was installed around 20 years ago. The FM transmitters that we've recently installed are a similar efficiency to the ones that they've replaced, but we've moved from air-cooled transmitters to water-cooled transmitters. And so the benefit of water cooling the transmitters is we move the heat that they generate. That's pretty good. I guess it's also a lot better for the environment, and it allows us to put the savings back into the network on other great things. It does. Yep. Terrific. All right, so you touched on a combiner a bit earlier, Matt. I think you may have been talking about a transmitter combiner possibly, but can you tell us a little bit about RF combiners and how they fit into the picture here? Yes, certainly. So the RF combiner is a passive device that we use to combine, which is clearly from their name, combine multiple services into a single antenna. So we would have multiple, for example, if we're looking at an FM combiner, multiple FM channels, all using their own transmitter, but the output of those would pass into the combiner, which mixes them together and sends that signal up to the antenna, which is then broadcast out to the public.
Ah, excellent. So what's the benefit of having a combiner system?
The main benefit is that you don't end up with multiple antennas on the tower, so you end up with lower tower loading. You don't have to maintain multiple antenna systems out on top of the towers. You end up with the equipment, more equipment inside the building, which is easier to maintain.
So it's a simple name, but it does give us a lot of things. Gives us a lot of flexibility to do a ton of things.
Yes.
Excellent. Now, so we've spoken about all the things on the transmitter site. We've touched on all the elements here. Obviously, on occasion, things do go wrong. And whilst we do design, when I say we, I'm speaking on your behalf, Matt and Jeff, design things so that they stay on as long as possible. But inevitably, things happen. And I guess, people would like to think that we have a plan to address things when disaster hits. So, Jeff, can you talk us through disaster recovery, some of the types of kits we have available and how we go about deploying them?
The way that we would respond to a disaster depends on the nature of it and, and also what you term a disaster, I suppose. So in the most simple form, if we've got a broadcast service off air, it might just be a matter of the local team dispatching a spare out to site. They could take that themselves, or depending on its location, we could dispatch that spare to a first-in maintainer and get them to do the work on our behalf. On the other end of the scale, I guess you've got things like total site destruction,
right,
or a partial site destruction, in which case, we've got things like containerized transmitters that are ready to deploy. They just need to be plugged into an antenna system and a source of mains, and they're ready to go. So we have two, for example, 5 kilowatt digital television transmitters that are containerized, one VHF, one UHF, and they can be deployed at any time. In terms of maintaining those, we would maintain them as we do any other service that's operating around the network. So we do regular testing on those to ensure that they're in a state that's ready for deployment at any time. But along with the big stuff, we've also got some smaller, lower power transmitters that we can dispatch at any time. These are not they're kind of distinguished from the spares that we have in the network. They're not rotated through the network as a spare as such. They're kept aside as a dedicated disaster asset.
Terrific. So is it just the transmitters that we have spares of, or do we have PI equipment and combiners as well?
Look, we do. We've got all of the above. My team specifically looks after the PI and transmitters, but other teams across the business have spare, structures, antennas, and the like.
So in the very unlikely event that something were to happen, then we do have the capability and the ability to restore services with essentially an equipment that covers every aspect of broadcast.
That's correct, Maz, and we've got a team of specialists in RF networks as well that's ready to support our field teams with the exercise as required.
As we said, inevitably sometimes things break and things go wrong. So what happens to the equipment, Jeff, when something happens to it, or let's say that the service has some problems and we've got to recover the item from the site? What happens then? Where does it go?
So, as I mentioned earlier, we've got a small team of specialists known as the National Repair and Calibration Centre, or NRCC. Their role is to gather the broken items from around the network and focus on their repair and calibration. So what we're trying to do with the NRCC is lift the responsibility of component level repairs from our field teams around the country. It is, after all, a specialist task, and that team has the specialist training and the specialist equipment that enables them to do that.
That's quite good.
On the calibration side, Maz, what we're working on at the moment is calibration used to be quite a manual task that would take up to a couple of days per instrument to do. Now, it's important as a business that we can trust our test equipment when we're doing measurements. We need to know that the numbers that we're reading are the truth. So once a year, all of our equipment gets a calibration. So what we're doing at the moment to speed up that calibration process is we're automating it by using Python in order to script these routines that can run in a matter of minutes as opposed to a matter of days per instrument. So it's a great time saving.
So you mentioned the repair centre and how the equipment goes back to them to fix up. So I guess in terms of the benefit to the wider network and also the teams that are out in the field, what's the benefit to them by centralising the repairs at the NRCC?
Well, I guess to us as a business, it means that our repairs are done in the most efficient and reliable means possible. But it also frees up time for the guys that are out there in the field. It means that they're not having to, get down to component level. They're not having to fire up their soldering irons and pore over the equipment manuals in order to get the repairs done. Our guys at the NRC are familiar with most of the gear in the network, and they've been trained in specialist soldering techniques, so they're the right people for the job.
We've covered most of your responsibility at the moment, but there is one aspect that we haven't touched on yet, and that's training. So obviously, being a very specialised team that you manage, can you tell us a little bit about the training that a lot of the teams receive just to keep them on top of the new bits of equipment and technology that come out into our network?
Look, I'm really proud of the work that our training team does. I think in 2022 there are a few businesses that have a technical training team, and we're one of the exceptions. The trend is with technical training is that we're moving away from face-to-face presentation. Don't get me wrong, face-to-face still has value, and it's always great for the attendees of our training to get their hands on the gear. But generally speaking, we're trying to move away from that face-to-face environment to online self-paced training. The advantage is, of course, that the attendees can run that training in their own time at a time that suits them, and we're not taking them out of the business for a period of time to sit down in the classroom effectively. So it's going really well.
Yeah, appreciate that, Jeff. Thank you for sharing. Well, look, we've covered quite a bit of ground. We've touched on everything that you look after and all the teams that you're responsible for, Jeff, and we've touched on the elements of the broadcast system with you, Matt. And so I guess for our viewers out there or our listeners out there, you've probably heard of transmitters before and maybe pies and possibly combiners, but perhaps not how they all come together and some of the intricate engineering that results in providing the redundancy to continue keeping signals going on and on. Lucky for us, Matt, Jeff and their teams do. They cover the entire broadcast network, and they get continued training to make sure they're on top of their game. So 2 thumbs up there. Jeff and Matt, thank you. BAI's Jeff Dale and Matt Betts telling us about the very important roles they and their teams play in keeping broadcast services on air 24/7, 365 days a year. As we know, no pie, no combiner, no transmitter, no transmission, no favourite shows. For more on what Jeff and Matt spoke about today, click on the link provided with the podcast on this webpage. If you have any questions on today's session, please get in touch with either Matt, Jeff, or myself. Catch you next time for episode 4, where we'll be joined by BAI's Chris Howe, who will be talking to us about what it takes to look after all the elements on a whole that makes the broadcast machine tick. Thank you.
Thanks, Maz.